All right. Hello, everyone. Thank you so much for coming along. It's an absolute pleasure to be here, even though technically at the moment it is 6:20 in the morning for me. We're going to blast on through that because who doesn't want to give a talk at something beginning with 6? My name's Nash. I'm a developer relations engineer at Datastax. Datastax, if you don't know, we're upstairs. We've got a little booth at the top of the escalators. Do please come and say hi to us. We're out there building a platform for AI, generative AI applications. And so as part of that, right now we have Astra DB, which is a vector database, and Langflow, which is a visual builder for that. And you will see a little bit of that as part of this talk. But if you are interested at all, then please go and have a chat with us upstairs. So what about this sort of world of generative AI then? First, I guess especially developing on it is pretty brand new compared to almost everything else we have in the world of developing. ChatGPT itself, like the interface, the user interface, was launched in like November 2022, which is less than 2 years ago, right? And then the API for ChatGPT, the sort of GPT 3.5 Turbo, was launched in March 2023, so that's 18 months ago. And this is moving so fast. We are discovering and working with this technology as it kind of continues to improve beneath us, which is kind of fun because even if something you did a few weeks or months ago doesn't exactly work, it might well do in just another couple of weeks or months. And so it's definitely reached the point where we can build and deploy useful applications. In fact, there's a bunch of talks on as part of this event, mostly today. I think there's another one tomorrow, where others are describing what they've built, and I can't wait to kind of see them and see what other people are working with. So 2024 is really very much a year of learning, I think, building and deploying these things to production. And so if you haven't tried that yourself, I kind of want to describe the process of actually building something with an LLM and some of the techniques that you need to know to help you build a successful generative AI application. And then as I do, I'm going to kind of demonstrate or build in the bit that durable execution is actually a really good match for some of the workflows that we need to build. As an aside, I do want to be honest, I'm not an expert on temporal. I'm more hanging out in the LLM section. But it's been quite clear as I've been building with it how well temporal and durable execution works with some of these flows and makes it so important. So for this talk, I just want you to leave with an understanding of like techniques for working with GenAI. And from my ideas of doing so using temporal, you can take kind of your experience, hopefully, and build a bit upon it. And so then you'll be prepared, hopefully, for some of the awesome stories that we'll hear later from other people talking about AI, and hopefully excited to build with a bit of generative AI yourself. And so let's get on to building with it. I want to start with an overview of like things you're going to need to know in order to work or develop with this. And then we should likely start that with the available models that we can kind of talk to. So if anyone's interacted with consumer kind of generative AI things before, you'll recognize most of these kind of things: OpenAI's ChatGPT and Google's Gemini, Anthropic's Claude. Cohere and Mistral are other options out there that don't necessarily have a consumer side to them. Mistral has open source models, which is very cool, as well as an API for them. And then some of your bigger providers, like AWS and Azure, kind of re-provide some of these services, or some of the more open source ones as well. So I think AWS does actually provide Anthropic Claude a bunch of times, but as well as Meta's Llama models. Azure has their OpenAI service, and Grok is a startup that's trying to make all those things much quicker, again, using the open source ones like Mistral or Llama. But most of these things, it's kind of hard to necessarily think about and pick one to use. But one little site I found, which is really useful for this, is called artificialanalysis.ai. And it kind of takes independent reviews of models on different kind of axes to compare them and help you choose. And kind of this top overall kind of set is quality against speed against price. It allows you to kind of pick between, like, do you want it to become quick, or do you want it to be cheap, or do you want it to be the best possible result? And then, kind of pick the best possible available out of that as well. And so OpenAI's GPT-4o sits right at the top end of quality, but also kind of near the top end of price as well. And one I found myself actually kind of experimenting with and playing around with a bit more often is Gemini's Flash 1.5, which absolutely sits at the bottom, the cheapest end and the fastest end of the price and speed things, and is still not bad. It's somewhere in the middle of that quality graph up there. So everything I've been doing for this talk is in 1.5 Flash, and that's kind of cool. And actually, for any of these providers of APIs for LLMs, it's really kind of super easy to just get involved with them. There's normally a library, and you'll see most of my code is in JavaScript or TypeScript, because that's what I work with most of the time. But normally there's a library. If not, it's an HTTP API. And with just a few lines of code like this, you can getting a response from an LLM. And so that's not necessarily the hard part. But if I can just switch to my screen for a second, I can show you, there we go, that I have a very simple generative AI flow set up in Langflow here. So Langflow, as I said, is a visual builder, which in this particular case takes a chat input, puts it through a prompt, feeds it to 1.5 Flash, and then gets an output, which is all very nice. It's very simple to do, and we can have a chat with it. I can just say, hey. Saying hello to it doesn't get a lot out of it, because it just says, how can I help you, which is cool. If you want some more interesting information, you can ask it a question like, tell me all of Taylor Swift's albums. And if you ask it something like that, it's going to hopefully bring back some kind of useful and factual response. And so we have like this top 10. And now I'm not an enormous Taylor Swift fan, for risk of alienating myself in a crowd. But even I know that Midnights is not the last one in 2022, and Speak Now 2023 is not the last album she released. And this is because these models have training data cutoffs. They don't know anything, or they have no training data that goes beyond the last point at which they were trained. And so obviously with this one, it's somewhere in 2023, as it knows about Speak Now, Taylor's version here. But we need to do some more things to deal with that. So if we can go back to the slides, please. Let's carry on. So that's pretty cool, but it's just not very useful. All we've done is hook up a chat interface to an existing model, which Gemini has done as well. In fact, actually, Gemini Online can access the internet, which is much better than what I was able to achieve just there, and probably would get the latest albums correct. This is not very useful yet. This is the development part of it. This is where we come in. And so it's actually good probably to step back and have a quick think about how these things actually work, at least at a high enough level to understand how to go ahead and work with them. So every time we talk to one of these models, every time we send text to it, the first thing it does is turn it into tokens. And tokens are sort of words or word-ish things. This is a sort of interactive example that OpenAI has on their site that shows you how the words are broken up into tokens. And it certainly shows that like many words mapped to one token are all one word at a time. And I just love their choice of indivisible as a word that is divided into several tokens. It's perfect. It's almost as if they trained the model themselves for it. The point about these tokens is that it's important to keep an eye on them, because that's normally where the costs come in both input and output tokens. And also, like, I'm probably going to speak about words and tokens sort of interchangeably, but really underneath it all, it's tokens that's happening. Because ultimately, what we do is pass these words to a model, they turn it into tokens, and then attempt some sort of fancy autocomplete on it. So the model actually has this whole neural network underneath, right, which ultimately produces a probability distribution over all the tokens available. And so we get this fancy autocomplete in which we pass it a string of tokens, and it comes up with what it thinks is the next most likely or near most likely token to return for that. And so if we say once upon a time, we feed all those tokens into the model, it might come out and say, okay, the next one is in, or in fact, comma in, if that's a token. And it's important to know that now that's not done yet. It's not done until it kind of thinks it's complete. It doesn't think, but you know what I mean. We pass the entire string back into it, the entire set of tokens back in order to get the next potential token, once upon a time in And we go, OK, now what's the next one? Every single time we get one new token, and we pass it back in to eventually get once upon a time in a world, and it's going to carry on from there. Knowing that it's always passing this stuff back is really useful when we come to prompting it later. But before we get there are ways to change this behavior slightly. Some models give different versions of this. This is the kind of available things for Gemini, where top K allows you to restrict the number of potential next tokens to that k number you provided. So if you want to say, I only want to pick the next one from the top 100 potential tokens, you can say that. Top p, on the other hand, is the topmost probability. So if you want to say, I only want to return tokens within the top 10% of available potential tokens, top p will do that. And then temperature is like how random inside the amount of available tokens the model is. So if you turn the temperature all the way down to 0, it's going to pretty much pick the absolute next most likely token. Very boring in a way. If you turn up to 1, which is its normal maximum, it can be a lot more random. It's picking from all over the place, and it's a bit more fun. And to break it down a little bit more simply, like low temperature or restricting top k gets a model that ends up a bit more factual. I should have put that in quotes. I really should have. It's not factual. It's sort of accidentally correct a lot of the time because it's just this probability distribution. But if that's what you're aiming for, if you're aiming for sort of boring and mostly likely, turn the temperature down, restrict the potential tokens. But if you want it to be more creative, if you want to generate stories or ideas, then turning that temperature up and not restricting those top k or top p is really useful. So it turns out really, beyond the model, we have a bit more work to do. Like that's pretty much all the knobs and whistles and whistles, the knobs and levers we have to play around with what a model can do. Beyond that, the model, as I said earlier, they don't really know stuff, right? It's just a probability distribution. But we can move that probability, we can change that probability by telling them stuff, which is exciting. This is where the actual prompt engineering comes into play. And prompt engineering also, I think, should be kind of quoted, but it's important to know how to work with a prompt. Different models will behave differently with different prompts, but the overall kind of ideas tend to be useful. And so the first thing is known as zero-shot prompting. It's basically what you would do if you are talking to a model or a chat or anything as a normal person, just making an instruction or asking a question. All of these responses, all these questions or responses were something I did pass to Gemini 1.5 Flash. And so when I asked it for a story about a friendly goblin, it did come up with the first word as grobnar, which is incredible that that's somewhere in the probability distribution. But grobnar wasn't just a typical goblin. Yeah, it turns out actually Gemini, most of the Gemini models, if you ask for a nice fairy story, they tend to pick a character, a young girl called Alira. And that's why I avoided that for this and got the friendly goblin instead. Go grobnar. You can ask a question, and if it's a very well-known question, like what's the capital of France, it's probably going to answer you correctly. It's just so unlikely it's not going to pick Paris. But we can make these a bit more achievable, a bit more obvious by using kind of one or few shot prompting. And this is the idea of giving examples to the model before expecting a result from it. And so in this particular case, I've given a set of pairs of countries and capitals, and then ended on a country. And this one was a bit annoying, because it got very chatty about the whole thing. In fact, it's treated me like I was playing some kind of game with it, game show. I'm like, you got it, the answer is Washington, D.C. I'm like, you answered it, what are you talking about? Let me know if you want to try again. Thanks, model, I guess. Like it's correct, but also weirdly condescending. But it kind of got the idea, right? It got that we wanted Washington, D.C. as an answer out of that. But this puts us onto a better kind of line of attack with the system prompt. Now, all kind of model providers have like an overarching system prompt above everything, but the system prompt that as developers we have has more power than user prompts, and so can drive the behavior of a model like this with more conviction, which is useful. And so in this particular case, I say, you are a capital city assistant that only respond with the name of the capital city for the country or state that you're provided. If I then go with the same input as I did before, it restricts its output to what it expects, which is just, in this case, Washington, D.C. And so that system prompt allows us to give better, clearer instructions as to how this thing should behave. And then we can take that further steps onwards to chain of thought prompting, which you might have you can use as a user as well, but it's more powerful again from the system. And in this case, I wanted to pick something that it wouldn't necessarily get on a first guess by asking a riddle. And so I told it it's a riddle-solving assistant, and it will be told a riddle, and before it comes up with an answer, like write down its chain of thought in front of us. And that is where knowing that for each new token produced, we put the entire string back in is really useful, because by the time it's written out what it was thinking, it's telling itself that back again and allows it to get to a clearer, more obvious answer. And so, what did we say the riddle was? Go back. The riddle was, you see a boat filled with people. It is not sunk, but when you look again, you don't see a single person on the boat. Why? Does anybody know? I did just flash the slide, but no? I'm not asking you to break down a chain of thought or anything. I can't hear, I'm afraid. If you did say it out loud, the answer is because everybody on the boat is married. There's not a single person on the boat. But in asking Gemini 1.5 Flash, in this case, to break that down, it said, you know, the riddle focuses on the boat and the people, and so it's probably something to do with the relationship between the two. Not exactly right. But then it goes, OK, it's full of people, then empty, implying a change of state or perspective. And so it's kind of getting there. And then it says, OK, the boat hasn't sunk, which rules out any event that would physically remove the people. And so at this point, it's worked out the people are still there, and it has to come up with some reason why they are. And it says the most likely answer is that everyone in the boat is married. So well done, Gemini 1.5 Flash. You got it through chain of thought. And I love that. And then this kind of chain of thought doesn't exactly lead on to, but it's a similar idea, is that any kind of chat experience you ever have with these models is also down to just feeding the previous chats back into it. It's almost as simple as that, because it only knows about things that previously happened in the chat because you tell it every single time you ask a new thing from it. And so that's kind of useful. And ultimately, it brings us to how we're going to control this with our own data. Because our own data is actually what's most important here about this. A lot of this is about data and data pipelines, and getting our data into these systems is the key to all of this. And that is, as we said at the start, Retrieval-Augmented Generation. It's a big fancy name, and we like to call it RAG, because that's much easier. And the idea behind RAG is that we gather all of the unstructured data that we have that the model doesn't know about. So that's more modern data, that is potentially private data, customer data, from wherever. We're going to gather it all. We're going to store it somehow. And then when a user makes a query to a bot like this, we kind of retrieve relevant data to that query, feed that query, provide that query as context to the model with the original query, and then the model generates a response based on that data, and I profit. But really, the difficult part about this is actually the top steps, which don't involve like talking to the model. We've already realized that talking to a model is just a few lines of code. It's a library, an API call. How do we get that data, and what do we do with it to make it useful? This is where our data pipeline comes in. So gathering unstructured data could be anything. It turns out a lot of businesses, it seems, have just PDFs lying around everywhere, full of important data that no one knows how to get out of it. But it could be web data. It could be internal kind of knowledge bases, anything like that. Gathering all that unstructured data and get it in one place as a start. You then want to sort of parse out of the HTML or PDFs or whatever you've got there, and then turn that data into chunks. It turns out when you have 10 pages of PDF or the longest Wikipedia article in the world, feeding that entire thing as context to a model actually makes it harder for the model to pick out the relevant thing inside of it. Turning it into chunks that have single or just a couple of ideas means that we can both more easily retrieve that data, but also allows the model to pick out what we want from it better. And so we turn it into chunks. And I've actually spent the last few weeks, aside from thinking about this talk, thinking quite a lot about turning lots of data into chunks. So if you're more interested in that, come and talk to me afterwards. It's a very weird subset of all of this. But yeah, we get small chunks. We then have to turn those chunks into vector embedding. Vector embeddings are long strings of numbers, which is not a very useful way of talking about them. Those numbers, though, are intended to capture the meaning of a piece of text or other content, but I'm mostly talking about text today. A vector in an embedding space is a multi-dimensional point or direction in space, multi-dimensional space. It's almost impossible to kind of really figure out or visualize in your head because we are stuck with these 3 physical dimensions here. If they're capturing the meaning, we can capture meaning in this point in space and then compare other kind of versions of meaning to that. there are APIs. So these are mostly also models that we have to deal with. And so there are APIs as well as local models you can run to create vector embeddings. This is just, it's very similar in a way to calling on, at least with the Google library for Gemini, it's very similar to calling on Gemini as it is to call on text embedding 004, their very excitingly named embedding model. But once you have that, it returns you, yeah, this point in space. And I'm going to go to 2 dimensions to show what I mean by kind of comparing them. Because in this, we have 3 vectors. And vectors are not just points in space, they are directions and magnitude. And so we have A, B, and C. And whilst it might look like A and C, if you were to compare them, would be the closest, that's only kind of true physically, but not in terms of meaning or direction. And so actually A and B are the most compatible. In this case, they kind of mean the same thing, but with different magnitudes. But you don't have to worry too much about this, because normally a vector database will handle this for you by doing the similarity comparisons for you using normally cosine similarity. It's all the trigonometry you wish you'd forgotten from school, or have forgotten from school. But it's normally handled for us. But this idea of vector similarity in which we get an idea of meaning, which is a point, a direction in space, a multidimensional space, we can compare other points to get the most similar to that. And that allows us, because it's based on that meaning, to retrieve relevant data to a user's query. And so in that pipeline, we go back to, we store all that into a vector database, and that allows us to use indexes to more easily query against it when we get that user query in actually on the user side. I'm just going to drop out of slides again for now and show you kind of how that works in real life. If I can go to the screen, please. Thank you very much. So what I've got is, actually, let's go to the code. I have a workflow, which is made up of going and doing all of those things I just said. It's a real simple workflow in which we get a URL, so we fetch the data from a URL, we then get the content out of the HTML, so kind of stripping it of all the tags. We turn it into chunks, we turn those chunks into embeddings, and then we store those embeddings in this case, Astra DB. And most of that is fairly straightforward. So if I go to the activities, we have things like get embeddings, which is actually handing out to get embed chunks here, which is calling on, in this case, the Google API for generating text embeddings. And in this case, we get a bunch of chunks, so we're doing a whole lot of reaching embeddings here. And this is the sort of thing that maybe you would turn into child processes, child workflows, if you weren't doing a real simple demo. Similarly, we have store it in the document. It's much easier to store all those documents in something like Astra DB because we can insert them all at one go, which is kind of nice. But what this actually looks like, that's some of my stripping HTML stuff. What this then actually looks like is I've got my workflow here on the left. I've got an empty database of web articles here. And I have, Wikipedia page on Taylor Swift. So if I just pop that in there and tell it to ingest, then my workflow will kick up, run it, and once it says it's complete on the one side, it'll be complete on the other. Go on, the internet. So it's doing stuff. It's taken time to get the URL. Have we gone offline is the question. Well, it won't matter because we've got a durable thing going on here. It's always the way, isn't it? Yeah, it's taken forever to go on the internet. Is it working? No, good. So this proves how nice and durable this whole thing is, because we've started our process, and as soon as I get back online, it will work. So if I go to the conference, which is Hyatt Meeting, somebody shout out the password to the Wi-Fi.
You can also go to replay conference, and the password there is durable escalated.
This one's replay 2024. Like that, capital R. All right, let's go to the internet. All right, so we're back on the internet, which means if I look at that, we've probably done a bunch of stuff since then. Oh, look, it's got the URL, hooray. Almost like I planned that. I didn't. But if I go and refresh, say, our database now, what we should find, this is still running. It's doing stuff. No, it's completed now. we should find that, yeah, we have now 228 records in here of vectorized data, including stuff about Taylor Swift. And so then finally, if I go to this workflow, this is a Langflow workflow again, and I'll explain why that is the case in a minute. We have another kind of workflow here in which I get an input from chat, I embed that query using Google, and do a search against Astra DB. We parse the data out of that, turn it into a prompt, send it to Gemini 1.5 Flash here, and turn it into a chat output here. And so now, if I ask them to tell me about all of Taylor Swift's albums, the internet will continue to work. And yes, it's doing it. And it gets our up-to-date data. So we have Tortured Poets Department there. We also have 1989 Taylor's version, which came out after the cutoff date, apparently, as well. And what's kind of fun about this is we can actually check out kind of the chunks of data that it was given. So it actually given a whole list of things here, as well as a filmography, which it didn't list because it wasn't asked for it, which is kind of nice. And so that's kind of how we take any data, up-to-date data, private data, and turn it into useful retrieval-augmented generation data. If I can go back to the slides to just finish up now. Cool. So yeah, so that's retrieval-augmented generation. I think building, the data is important, of course, and building that as part of a pipeline allows us to not worry about the hundreds of network requests I made once we actually reconnected to the network. And yeah, so that's it. So building chatbots is not the end game to generative AI. I have no doubt that I think this is just the first thing we see and we're excited about it. There's much more it can do and much more we can build with it. And that's why I'm excited for all the other kind of talks on this stage this afternoon about that kind of stuff. Or even actually Frank's talk, which came before lunch up here as well, which is really good. Data lies at the heart of so much of this. It turns out the actual AI models, once we understand what we're doing with them, just need us to feed the right data to them to get the right answers out of them. And we can consider further ways that we could apply pipelines to this kind of example. I could be storing that URL and then scheduling like a check once in a while to go kind of update, because I'm pretty sure the Wikipedia page on Taylor Swift is very busy. And we can use that to strip out the old stuff, enter the new stuff, so our knowledge base is always up to date. I don't think, and I use the Langflow workflow for the actual chat, because that actually kind of needs a bit more kind of interactivity with the user. We need to get data back to the user as fast as possible. It didn't quite show it in the Langflow example there, but most of the models give you a streaming API as well as just a regular kind of text response API. And using that streaming API to send data immediately back to the client is a better experience. But there are many other workflows we can put these LLMs into, which can be done in batches or in the background, much like, again, check out the videos for Frank's talk earlier on kind of the summarization they're doing at ZoomInfo. It's really interesting. So now I think is the time to build. Working with LLMs now just means working with data in a scalable way, and doing so using pipelines and durable execution is a great way. Retrieval-augmented generation is a technique that means taking that up-to-date or private data that a model couldn't know about in its training set, storing it in such a way that we can query by that meaning, query for similar data, and using it to provide, using that data to provide context to the LLM. And the way to do that also involves our vector databases, things like Astra DB, which allow you to store and work over the indexes of the vectors to retrieve them easier and faster. We can use that in chatbots, but there are many other ways as well. And durable execution means that that data can just look after itself, regardless of the number of network calls or flaky LLMs we have to deal with. And so that's all I've got for you. Again, my name's Phil Nash. I'm a developer relations engineer at Datastax. We have a booth up the top again. Please come and see us. We've got a raffle. We're giving away stuff. We've got socks. And I'd love to chat with you about this afterwards. So thank you very much. Thank you.